car is stopped at a stop sign and a truck hits the car from behind, pushing the car into the street at 20 meters per second. We want to find out how fast the truck was going just before the collision, assuming that the collision was elastic. In an elastic collision, the two objects move together for just a short period of time and then they move away from each other. We have the mass of our car and then we have the mass of our truck. And this is our truck and our car. They're both moving in the X direction. There's no Y component in this problem. And we have our initial car velocity, which is 0 because it's at rest. It was at a stop sign. And then we know that the final car velocity is 20 meters per second because the truck pushed it into the street at that speed. We don't know the final or initial truck velocity. We have to find those using these equations. So when we have an elastic collision, the relative velocity should be the same before and after the collision, but the final velocity is going to be in the opposite direction. So we use this equation. The initial velocity of object 2 in the X direction minus the initial velocity of object 1 in the X direction is equal to a negative final velocity of object 2 in the X direction minus the final velocity of object 1 in the X direction. In our case, our object 1 is the car and object 2 is the truck. So we're just going to plug those in for 1 and 2. And we know that the initial car velocity was 0 because it was at rest. And then we're just going to distribute our negative sign and we get a negative final truck velocity plus a final car velocity. So then we're just going to solve and we get our initial truck velocity is equal to a negative final truck velocity plus a final car velocity. So we can't go any further because we don't know what the final truck velocity is, but we do know what the final car velocity was. So now we're going to have to use another equation to find the final truck velocity. So we're going to set our two momentums equal to each other. So we have the initial truck momentum plus the initial car momentum is equal to the final truck momentum plus the final car momentum. We know that momentum, or P, is equal to the mass times the velocity. So we're just going to plug in mass times velocity for the P, and we get the mass times the velocity of the truck initially times the initial mass times velocity of the car is equal to the truck's final velocity times its mass plus the final car velocity times its mass, and they're all still in the X direction. So then we just plug in our numbers and we have the mass of the truck times the initial truck velocity, which we don't know. So we're just going to leave it as VTI in the X direction. And our initial car velocity was 0, and anything times 0 just cancels out. And then we have it equal to the final velocity times the mass. We know the mass, but we don't know the final truck velocity, so we're just going to leave it as VTF in the X direction plus the mass of the car times the final velocity of the car, which was 20 meters per second. So then we're just going to go ahead and add multiply these two together, and we get 3.0 times 10 to the 4th. And then we're going to distribute our 2.0 times 10 to the 3rd to what we have in parentheses here. And we got this from up here where we found the initial truck velocity was equal to the negative final truck velocity plus the final car velocity. So we just plug that in here and then we distribute. So then we have the negative final truck velocity times its mass, and we went ahead and just multiplied the mass times this 20.0, and we get 4.0 times 10 to the 4th, and then this just comes down from over here. So then we're going to add our negative truck velocity times the mass to the other side, and we get 4.0 times 10 to the 3rd times a positive final truck velocity plus our 3.0 times 10 to the 4th is all equal to 4.0 times 10 to the 4th. And then we're going to subtract 3.0 times 10 to the 4th from both sides, and we get 1.0 times 10 to the 4th is equal to the final truck velocity times 4.0 times 10 to the 3rd, and then we're going to divide both sides by 4.0 times 10 to the 3rd, and we're left with the final truck velocity equals 2.5 meters per second. So now we have to take what we found here and plug it back into this equation from the beginning. So we're going to come over here, and we have our initial truck velocity in the x direction is equal to a negative final truck velocity plus a final car velocity. So we found our final truck velocity was 2.5, and that's going to be a negative 2.5, plus our final car velocity, which was 20.0. We add these two together, and we get an initial truck velocity is 17.5 meters per second, and that's how fast the truck was going just before the collision.